Imagine walking into a garage and seeing a massive 1,000 horsepower engine sitting on the concrete. It is incredibly powerful, but it's missing a steering wheel, brakes, and a chassis. You can't actually drive it. This is exactly where we are with large language models like GPT-4 or Claude. On their own, they are just raw, unharnessed power. This missing infrastructure explains why the first wave of generative AI struggled. Companies threw these massive models at random problems to create flashy demos, but they optimized for novelty over utility. They built empty chat boxes that left users staring at a blank page. Data from Sequoia Capital shows that most people tried these early tools out of curiosity and never returned. The daily active user ratio plummeted to just 14%. Without a way to connect the AI's output to a downstream action, like updating a database or sending an email, an open-ended chat box is an intimidating, ineffective tool for real work. Intelligence alone isn't a product. To make these models useful, we have to build a functional car around that raw engine block. Driving an AI requires specific components. You need a user interface to act as the steering wheel and safety guardrails to serve as the brakes, ensuring the model doesn't hallucinate or leak sensitive data. The most critical piece of this assembly is the chassis, the vector database. This is what provides the structural connection between the AI engine and your actual work. A traditional database works like an alphabetized filing cabinet. It looks for the exact word bank on a piece of paper. A vector database organizes information as a web of concepts. It understands context, distinguishing between a financial institution and the side of a river based on the surrounding ideas. This architecture gives the AI a functioning long-term memory. It allows the model to recall the context of your specific documents and internal workflows, rather than just performing simple keyword searches. When the engine is connected to contextual memory and a safe interface, you have an Act 2 product, a tool that actually moves work forward. Building these systems once required an entire team of software engineers. You needed experts to manage the data pipelines, the UI, and the integration. Modern AI-powered development environments like Cursor have removed that requirement. They enable vibe coding, where software is built through plain English instructions and visual references rather than manual syntax. Using AI agents that understand frameworks like React Native and Expo, a single English instruction can generate code for both iPhone and Android simultaneously. You can provide a screenshot as a visual reference, and the AI handles the underlying architecture, connecting features like document scanners and PDF exports. This bridges the gap between a raw idea and a multi-platform product without requiring any manual coding from the user at all. The AI indexes the entire codebase, memorizing how every file relates to the next. If the app throws an error, you click a single button. The AI identifies the broken link and applies the fix automatically. The technical barrier to entry has disappeared. Since the AI handles the execution and error correction, anyone can now bring a complex functional application to life. If the technical walls are gone and AI can build and process data instantly, we face a logical question. Why hasn't every employee been replaced by an algorithm? We can see the limits of this transition in the fintech giant Klarna. They initially moved toward an AI-first customer service model to automate as much of their global volume as possible. On paper, the success was undeniable. In 1 month, their AI handled 2.3 million conversations in 35 languages. It resolved issues in 2 minutes instead of 11, effectively doing the work of 700 full-time human agents. Financially, it was a massive win. Klarna projected that this single automation would deliver $40 million in profit improvement for the year. These staggering efficiency metrics create a highly convincing illusion that complete human automation is just a mathematically solved problem. Current AI acts as a brilliant, forgetful intern. It works 24/7 and recalls every policy instantly, but it is rigidly mathematical. When a customer is panicking because their card is blocked in a foreign country, they don't want a robot reciting terms of service. They need empathy. The AI lacks the human element required to handle high-stakes, emotional edge cases. This missing empathy forced Klarna to reverse course. Despite the $40 million in savings, they chose to bring human agents back into the loop to protect their brand quality. The data shows that speed isn't everything. 86% of customers prefer empathy over raw speed when resolving sensitive or complex issues. This has led to the human hybrid model. AI handles the routine logic, using sentiment analysis to track a customer's tone. The moment it detects confusion or stress, it routes the history to a human agent who provides the creative problem-solving the AI lacks. AI provides the speed, but human talent provides the empathy and trust required for a sustainable business. This shift creates director's mode. Instead of executing mundane tasks, you manage multiple AI agents at once. You can have 3 different models racing to solve the same problem simultaneously. Your role is to evaluate their distinct solutions. You apply your human taste, judgment, and overall strategy to decide which path fits the project's goals. This is a mechanical exoskeleton. You wear the technology to amplify your reach while remaining the one steering the machine. It gives you superhuman capabilities, but the impact is still guided by your hand. You must remain in the driver's seat. You are the only part of the equation capable of providing creative direction and high-level oversight. The heavy lifting is now handled by the machine. With the barrier to entry gone, what is the first impossible idea you are going to build tomorrow?